Hi, I'm Doug from the product team here at Sophos, and today we're going to be taking a look at the Sophos AI Assistant. This tool is part of our AI native XDR platform, which enables you to quickly detect, investigate, and respond to multi-stage threats across all key attack vectors in the shortest time. Now, the Sophos AI Assistant provides support and advice as you work a case. It was designed in partnership with Sophos' frontline analysts and makes it easy for users of all skill levels to get the information they need and neutralize adversaries fast. So in this demo, we're going to walk through an end-to-end investigation of a common real-world situation, showing how the assistant helps you every step of the way. A very basic first step is to simply ask the assistant which sorts of questions you should be asking in order to investigate the case. We've done that and received a nice long list of possibilities here. Another good early step is to ask the assistant to summarize the case. That'll give us a good overview of what's going on. We've got information about the detection, the entities affected, the case timeline, and some other data. One of the important discoveries here is the detection of this wscript.exe process. Let's dive a bit deeper and ask the assistant to analyze the process tree, specifically to look for persistence. Looks like we've got a clean list of registry entries here. The assistant then asks if we'd like to analyze scheduled tasks and startup programs. Yes, we do. The assistant returns a list of scheduled tasks here. Of those, we've got a few suspicious findings here. Adobe Update Manager might sound legitimate, but the fact that it uses a script to launch the calculator app is definitely suspicious. This next one runs a script associated with the detection, so pretty clearly malicious. Windows Update Service. Again, sounds legit, but not when it runs an obfuscated PowerShell script. Then a suspiciously named file that's a VBS script in the temporary folder, and a maliciously named batch script. We then get a nice summary of persistence indicators. Next, let's ask if there are any suspicious files in the temp directory that shouldn't be there. Nope, looks clean. How about processes running from unusual locations? A live endpoint query returns all the Windows processes currently running and spotlights a handful that warrant a closer look. We'll ask if any of the processes in this case are making network connections. Again, looks good. Let's ask about unsigned or suspicious DLLs. Yep, looks like we have a handful right here. A few that look pretty clearly malicious and then a couple that look a bit suspicious. Drilling deeper, we'll ask about recently modified system DLLs. Nope, all good. Any communication with command and control servers? Nope. What about unauthorized services listening on network ports? We've got some legitimate services, some suspicious services, and some unusual activity. Next, let's see if any new user accounts have been created, especially with admin privileges. We've got one here that's definitely suspicious. An admin account created shortly before the suspicious script was detected, and one that's not quite so obvious, a guest account. There's some advice about what to do next to get to the bottom of the accounts that have been created. Let's now determine whether there have been any changes to account privileges or group memberships. It seems that the guest account was elevated to local admin shortly after the suspicious script was detected, and the admin account that was created was added to the remote desktop users group. Okay, we've definitely got some suspicious activity going on. Let's drill down further and ask about service accounts being used interactively. We're now seeing some highly unusual behavior. The system account and the remote management service account are both being used in unexpected ways, indicating malicious activity. Let's look for evidence of cached credentials or pass-the-hash attacks. We've got a hit on both, plus an additional authentication event. Notice the account names here. Those sure do look familiar. And unsurprisingly, we conclude that this is highly suspicious activity. Okay, let's see if there were any attempts to disable security software. Windows Defender was tampered with and event logging was disabled, likely to cover the attacker's tracks. What about user account control settings? UAC was disabled for this user account, which indicates malicious intent. The assistant goes an extra step here as well, correlating the UAC event with the Windows Defender tampering and the elevation of this new user account. Things are getting a bit more obvious now with the assistant calling out the UAC behavior as a significant red flag. If we ask about the disabling of audit logs and clearing of log files, we see even more suspicious activity. System path variables have been changed, another indicator of malicious behavior. We've got a highly suspicious modification to Windows services. including a temporary directory executable and a fake Adobe updater. Any suspicious browser extensions or plugins? Yes, 2 in Chrome and 1 in Edge, all with overly permissive access. Let's examine whether any files were downloaded around the time of the incident. Yep, we've got a bat file, an executable, and a document likely used to trigger the malicious script. The boot configuration data was changed, indicating an attempt to load components during the boot process, specifically a bootloader image in the temp directory. Integrity checks and secure boot have been bypassed as well, which allows the loading of unsigned drivers and components. So in just a few minutes here, we've thrown a variety of queries at the assistant, which in turn has uncovered some definitely malicious activity. Each answer from the assistant contains advice for next steps, which we can use to further investigate and remediate the incident. Thanks for watching, and be sure to check out sophos.com/AI for more information about the Sophos AI Assistant and other unique AI technologies we've developed.